Welcome to Byte-Sized, a podcast showcasing the people behind, the emerging challenges of, and opportunities within global digital infrastructure industries. By connecting industry experts of today with the infrastructure designers of tomorrow, we hope to begin shaping a global internet that is truly sustainable, equitable, and resilient. I'm your host, Michael Brand. As the demand for data centers continues to increase due to developments in emerging technologies like artificial intelligence, large language models, and 5G, the data center industry is constantly looking for places to build new data centers. Yet this can be extremely difficult, as data center designers have to find land, materials, power sources, and permits among other challenges, making the process time-consuming and expensive. One solution that is being considered is retrofitting old buildings instead of building new data centers. This potentially holds environmental and community benefits, but retrofitting data centers only works in some instances and requires a unique set of skills. This leaves us with a big question. If building new data centers is becoming incredibly challenging, and old data centers are struggling to keep up with emerging computing demands, where and when should buildings be retrofitted, and what types of thinkers are needed to conceptualize how to do so effectively? Today, I'm excited to speak with Phil Koblence. He's been a leader in the data center industry for almost 30 years. He co-founded NYI, a data center operator which has grown into a robust network in key national and international markets, and he's undertaken several high-profile retrofitting projects, including 60 Hudson Street in New York City, a historic co-location and interconnection hub. He's also the co-founder of the Nomad Futurist Foundation and CEO of Critical Ventures. Welcome to the podcast, Phil.
Thanks for having me, Michael.
So you've been in the industry for almost 3 decades. How have you seen data center design considerations shift over the late 1990s to now, especially in terms of retrofitting?
Yeah, I mean, thanks for reminding me that I've been in the industry for 30 years.
If it makes you feel better, you don't look a day over 30 to me.
Right, it's the same haircut I was born with, if that helps. Obviously, in the current inclination of what a data center has become, power is the biggest constraint in a way that it wasn't necessarily when we started 30 years ago. You know, with the emerging technologies of AI and all that, I think the focus is not just on bringing more power into the data center, but, you know, heat and temperature and environmental controls in a way that I think has evolved with the increased, you know, density and compute power of everything from, you know, the high capacity engines of AI, the NVIDIA GPU chipsets, to the fact that, you know, when I started, the entire data center probably wasn't processing as much compute potential as I have in my pocket with an iPhone. So it's been an evolving process, no doubt.
And can you talk a little bit about what retrofitting looks like? What is that process?
There are a number of ways you can look at it. One is, and this has come up a lot because with COVID and the like, there's been a significant disruption in just commercial real estate usage across the board. So it's fundamental to these large, you know, call it tier 1 NFL cities that have a bunch of dormant office spaces and trying to determine whether there's a digital infrastructure use case. But the two primary things that I would call out is whether you're trying to retrofit something that was a data center or something that was just a standard office space. So I'll start with the data center element of it. If you have a data center that was built at, I can't believe I'm old enough to say this, the turn of the century, which is when a lot of the kind of initial carrier hotel data center sites were built, and every major city has one. Many non-major cities, kind of tier 2 and tier 3 cities have them. In New York, it's 60 Hudson Street and 111 8th. In Chicago, it's 350 Cermak. In Seattle, it's the Westin Building. In LA, it's 1 Wilshire Street. What is important about those buildings is the network inertia, the amount of network connectivity that's in those buildings because of how long they've been around. And where they struggle to keep up is with the kind of evolving, ever-increasing power needs. The way to really maximize those data centers, their lives, is to come up with unique ways of leveraging a finite amount of power. One, on the cooling side, is by taking into account super low-tech solutions like containment, whether it's cold aisle containment or hot aisle containment. That's like the easiest way to start because you get a runway out of existing cooling infrastructure. So if you have a raised floor environment that was built in, 1999, and it was built at a time where, there wasn't much focus on airflow dynamics, where the cold air needs to come in to a server and where the heat exhausts. You can fairly quickly manipulate a data center so that you set up literally rows of cabinets where the intake side of them are facing each other. They call that a cold row, because if you think about a server as something with a lot of fans in it, it pulls in cold air from the front and exhausts hot air out the back for the most part. And you want those devices facing each other. And a raised floor suggests that cold air is coming from the floor. So you're essentially using the raised floor as an aggregator of cold air. So you actually have air conditioning units that blow down, and it makes it the easiest way to kind of get airflow throughout the data center. The most effective way to get runway out of that type of environment is to literally put a box around the row of cabinets. So you have these cabinets that are facing each other. You put a box around it. If you're really fancy, you put doors at either side of it. If you're not so fancy, you literally put butcher sheeting. So rubberized material that you can walk through so you can do work on it. And all you're doing is you're trying to capture that cold air and avoid the mixing of air. And when I got into this industry, if you told me that one of the primary focuses that I had was going to be airflow dynamics, I would have said you were crazy. I had no interest in any of that stuff. But you quickly realize that when you walk into a data center, like the air just being cold doesn't do anything. It doesn't matter. The humans do not need to be cold. What needs to be not just cold, but consistent is the area kind of 5 feet up in one of those cold rows to make sure that you can add runway in terms of not having to leverage a significant amount of your finite power resources on adding additional air conditioning equipment to keep that temperature consistent. And you're also able to handle, more compute power that generates more hot air by keeping a consistent cool temperature on the intake sides, which inevitably reduces the air temperature on the exhaust of those units. So it's a lot of food for thought there in terms of like one of the easiest ways to retrofit that I know was not top of mind of mine when I got into this crazy industry with blinky lights because, I thought computers were cool.
So in many ways, it seems like retrofitting is an obvious solution. You remove many of the barriers in terms of building new data centers. You have a lot more control over your data center in some cases. But it still seems like new data centers are the dominant strategy when it comes to meeting that computing demand. What are kind of the barriers that are preventing wider adoption of retrofitting today?
Yeah, look, I think one of the things you have to understand, especially if you're new to the data center industry, is that it is not a single monolith. It is not one type of thing. And I think a lot of people, call them civilians, if you will, that have not really been engrossed in this world, just think of data centers as all the same. The data center that's in 60 Hudson Street, that's been there since, 1987 is the same as the type of data center that, Amazon or Meta or Google are building today in Northern Virginia or Phoenix or any of these, Ohio, any of these hot growing data center markets. And they're not. And the reason they're not is because the workloads and the use cases for those data centers are entirely different. The type of data, it is going to be really difficult, if not impossible, to take an existing kind of commercial building, unless it's got like a really unique kind of original use case, and retrofit it to be able to support a large language learning model that's leveraging a ton of, NVIDIA Blackwell CPU chipsets, because those things require upwards of 80 to 100 kilowatts in a rack. I think Jensen Huang at the GTC summit in Northern California earlier this year suggested that they're moving towards a design of 600 kW in a rack. Just to give you some sense of that, a typical house in the United States in total has 20 kW of usage. My generator outside is 22 kW. And there's a 3-floor house with all sorts of stuff in it. So they're talking about like multiple times, 30 times that amount in a single cabinet of stuff. So that's going to be a really difficult standard, an impossible standard to retrofit towards. That being said, it's not the only use case. I think what we have to understand is the cycle of like what data centers are used for today. Essentially, like if you take it, if you peel it like 15 layers back, is all about kind of understanding what data is being generated and how to manipulate that data. Either that data is being used to do what's called inferencing at the edge, which is immediately manipulated in order to give you feedback, or you are moving that data to these large language model sites that are in the Midwest, in Texas, in some of these areas that have Moses Lake, Washington, and these areas that have a significant amount of power, a significant amount of space in a really cost-effective way. But that's not really where the data is generated. The data is generated on my Oura Ring and on my phone and on my, refrigerator that's telling me when I'm out of milk. And that data tends to be concentrated where people are. Because people are the data generating machines, the engine that kind of drives the need for all of these data centers, and the immediacy of the aggregation of that data and then the transfer of that data to the large language models are the areas that those inferencing sites in major cities where there are heavy concentrations of people. Those are the areas that lend themselves to retrofitting more because the mechanism through which you are kind of aggregating that data and then moving it does not necessarily take the amount of power that you need for the large language models. So there are workloads across the spectrum, whether it's, a content provider like a Netflix that needs an edge site in a major city to be able to reduce buffering. So when the next episode of Stranger Things comes out and everybody wants to watch it, it's as close as possible to you. So there are those use cases, but there's an entire gamut of corporate use cases, low latency connectivity use cases through financial services and otherwise that make data centers and the infrastructure that runs within them that are not like super power hungry, that can still survive the kind of 5 to 10 upward, maybe up to 20 kilowatts in a rack. And those are the types of use cases that lend themselves towards retrofitting because you don't necessarily have to build those from scratch because the power capabilities and certainly the network infrastructure that has been built over decades exist in those areas.
It sounds like in many ways, the retrofitting process requires a variety of different thinkers with a variety of different skill sets. We're developing this podcast for students who are interested in making a difference in the digital infrastructure landscape. What types of people could help address the challenges in retrofitting data centers?
There is no shortage. Everyone from like the super technical folks that want to understand like how data is being used and what the kind of use cases of the future are, to the kind of the blue collar end of the spectrum, electricians and plumbers and mechanical engineers, everywhere in between, architects and design folks, city planning, that kind of. We talk about this on the Nomad Futurist side a lot, is the data center is one of these industries that is unique in that it has every possible subvertical in it, from, marketing and business and sales and finance and legal. And if you have a mindset that understands how data center works, it is a superpower within those kind of crossover industries, all the way through the super technical and, network design and architecture and all that. So I think particularly with young folks in college now that are looking for a career path that grew up as what we call digital natives, only have a lived experience in a world that was, enabled by digital infrastructure. I think their secret sauce is not a specific knowledge of any one, technology, but a perspective on how they use technology that can be applied to whatever their lane is. So if they have a design focused mentality, there's plenty of opportunity within the digital infrastructure segment. If they have a physical kind of mechanical, electrical mindset, then there's no shortage of opportunities within the digital infrastructure industry. And if they have a business focused or business oriented mind, there's no shortage of opportunity to how to leverage anything from new data center financing and construction to unique ways of, retrofitting and leveraging existing sites in order to make them relevant to today's digital economy.
Thank you so much for joining us.
Thanks for having me, Michael.